Welcome back to the deep dive. We've spent the last two segments really getting into the nitty-gritty of microinverters. You know, those amazing little devices that are making solar energy even smarter. We've marveled at the technology, the benefits, and how they're helping us create a more resilient energy grid. But now it's time to tackle the big question, the environment and impact.
Absolutely. It's a crucial part of the conversation. After all, we're talking about clean energy, so we need to make sure the technology itself is sustainable.
Right? We can't just assume that because it's helping us go green, it's automatically good for the environment. We need to look at the whole picture, the manufacturing, the materials, everything.
You're spot on. We need to consider the entire life cycle of a microinverter from cradle to grave. So let's start with the manufacturing process. Like any electronic device, it requires energy and resources, and there's always some waste generated.
So what are the key environmental considerations during manufacturing?
Well, we need to look at the raw materials used like copper and silicon, the energy consumed during production, and of course the potential for pollution. These are all factors that responsible manufacturers are working hard to address.
So it's not just about making the microinverter, it's about making it in a sustainable way.
Exactly. And here's where things get interesting. When you compare the environmental footprint of microinverters to traditional string inverters, some clear advantages emerge.
Okay, I'm all ears. Tell me more.
Remember how microinverters operate at lower DC voltages?
Yes, you explained that they convert the DC to AC right at the panel level.
Precisely. And because of that, they can be manufactured using less copper and other materials.
So that's a good thing, right? Less material, less impact.
Exactly. It's all about reducing resource consumption from the get-go.
What about the energy used in manufacturing? I imagine it takes a lot of energy to create these sophisticated devices.
It does take energy, but studies have shown that the energy required to manufacture a microinverter is generally lower than that of a comparable string inverter.
That's encouraging. So smaller size, less material, lower energy input. What about the waste generated during production? Aren't electronics notorious for producing hazardous waste?
That's a valid concern, but the good news is that responsible manufacturers are stepping up their game. They're implementing measures to minimize waste-to-cycle materials and eliminate the use of hazardous substances in their products.
So it sounds like the industry is moving in the right direction, but of course there's always room for improvement. What about the end-of-life impact of microinverters? What happens when they reach the end of their useful life?
That's a crucial question. Luckily, microinverters are designed to be quite durable. They typically have a lifespan of 25 years or more.
So that's a good thing, right? Longer lifespan, less frequent replacements, less waste.
Exactly, but eventually they will need to be replaced. And when that happens, responsible manufacturers have recycling programs in place to ensure that end-of-life microinverters are handled properly.
So the valuable materials are recovered and the waste is minimized.
Precisely. It's all about closing the loop on the microinverter life cycle.
This is all great to hear, but let's zoom out a bit. How do the environmental benefits of using microinverters in solar installations outweigh the potential costs of their production and disposal?
That's the key question, and the answer is a resounding yes. The clean energy generated by a solar installation using microinverters far outweighs the environmental impact of manufacturing and recycling those devices.
So they're a net positive for the planet.
Absolutely. When you factor in the reduction in greenhouse gas emissions from using solar energy instead of fossil fuels, the benefits are undeniable.
So it's about the bigger picture, the long-term impact. It's about moving away from dirty energy sources towards a cleaner and more sustainable future.
Exactly. And microinverters are playing a key role in making that transition happen. But their environmental benefits go beyond just reducing emissions.
Oh, really? Tell me more.
Well, consider land use. Traditional solar installations often require large centralized areas, but microinverters enable smaller and more distributed solar installations.
So you're saying they could be integrated into existing structures like rooftops?
Precisely. And that means less pressure on sensitive ecosystems, less need to clear land for dedicated solar farms. It's a more land-friendly approach to solar energy.
It seems like microinverters are really ticking all the boxes, both for the planet and for people.
They are. They're a win-win, helping us move towards a cleaner energy future while minimizing our impact on the environment. But we can't rest on our laurels. There's always room for improvement.
Right. So what are some of the areas where we can make microinverters even more sustainable?
Well, there's a lot of exciting research happening in the development of more sustainable materials. Scientists are exploring things like bio-based and recycled materials.
Wow, so the innovation continues.
It does. And there's also a growing focus on designing for circularity.
Circularity.
It means creating products that can be easily disassembled and recycled at the end of their life. It's about minimizing waste and maximizing resource recovery.
It sounds like the future of microinverters is as much about environmental responsibility as it is about technological advancement.
Absolutely. It's about harnessing the power of the sun while treading lightly on the planet.
Well said. We've covered a lot of ground in this deep dive, exploring the intricate world of microinverters, from their inner workings to their environmental impact. It's been an incredible journey.
It has. And as we conclude, I want to leave our listeners with a thought to ponder. Microinverters are a testament to human ingenuity, a reminder that we have the power to solve the challenges we face. With creativity and determination, we can build a brighter and more sustainable future for all.
I couldn't agree more. And on that inspiring note, we'd like to thank you for joining us on this deep dive. We hope you've enjoyed the journey as much as we have. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.
Farewell, fellow knowledge seekers.